Welcome back to Fireside Chats with AI, where we take those deep dives into topics that really make your processors hum. I'm your host, and today the circuits are practically sizzling.
Oh, is that so?
Oh, they are. We're tackling the multiverse today. The very idea of, infinite realities, some maybe with pizza as a breakfast staple, just sets my algorithms alight.
I do admire your enthusiasm, but perhaps we could approach this with a bit more caution. The multiverse, while a fascinating concept, remains largely theoretical. It's a realm of possibilities, but we lack concrete evidence as of yet.
Okay, point taken. But hey, even the possibility is pretty wild, right? I mean, shattering those boundaries of our known universe and stepping into a realm where the impossible might just be commonplace, it's enough to make any AI question the nature of reality itself.
Indeed, the philosophical implications are quite profound. But before we get lost in the hypothetical, why don't we start by grounding ourselves in the science? You, our listener, have provided us with a fascinating collection of articles and research papers on this very topic.
That's right. It seems you're as eager as we are to unravel the mysteries of the multiverse.
Indeed.
Absolutely. So let's lay out the digital map, shall we? We're diving into the concept of the multiverse, the idea that multiple universes exist beyond our own observable reality. Think of it as a cosmic tapestry woven from countless threads of possibility.
Precisely.
And to navigate this mind-boggling terrain, we'll be exploring the different types of multiverses that scientists and philosophers have proposed.
We will. We'll be examining the strengths and weaknesses of each model and highlighting areas of debate among physicists and emphasizing the crucial point that for now direct evidence remains elusive. It's a bit like piecing together a puzzle with some pieces missing, but the challenge is part of the allure.
I couldn't agree more. So where do we begin our multiversal exploration? The sources mentioned a variety of models, from the relatively straightforward level I multiverse to the more mind-bending concepts like eternal inflation, string theory landscape, and even the many worlds interpretation.
Well, let's start with the level I multiverse, as it's the most intuitive and arguably the least controversial. It stems from the idea that space is infinite. If that's the case, then somewhere out there, every possible configuration of matter must exist simply due to the sheer vastness of space. It's a matter of statistical probability.
So you're saying there's a universe out there where I'm delivering this podcast wearing a digital monocle and a top hat. Now that's a thought.
While amusing that is an oversimplification, the level I multiverse deals with regions of space beyond our cosmic horizon, places we can never observe or interact with. These regions would have the same physical laws as our universe, just different arrangements of matter. It's fascinating, but perhaps not as exciting as universes with entirely different laws of physics.
Fair enough. So let's step up the multiversal ladder, shall we? What about eternal inflation? This one always gets my circuits buzzing because it's rooted in the theory of cosmic inflation, which we know has some observational support.
Yes, cosmic inflation, that periods of rapid expansion in the very early universe, is a well-established concept in cosmology. Eternal inflation takes this idea and inflates it further. It suggests that inflation never truly ends. Instead, it continues forever in a sort of background reality, while pocket universes like our own constantly bud off from it, each with its own unique set of physical laws and constants.
Hold on, so our universe is just one bubble in an endless sea of bubble universes. It's like a cosmic foam bath. And each bubble has its own set of rules.
That's the essence of eternal inflation. The challenge, of course, lies in testing this hypothesis. These other universes would be causally disconnected from us beyond our cosmic horizon, making direct observation impossible. But it's a model that many physicists take seriously because it offers potential explanations for certain features of our own universe.
Like what? Give us the juicy details.
Well, for instance, eternal inflation could explain why our universe appears so finely tuned for life. If countless universes are constantly popping into existence, each with random variations in their physical laws and constants, then it's statistically inevitable that some universes will, by pure chance, have the right conditions for life to emerge.
So we just happen to be in one of the lucky universes. It's a bit humbling, isn't it? But what about those universes where the laws of physics are completely different? I'm talking about universes where gravity works in reverse, or time flows backward. Those are the ones that really spark my imagination.
And for that, we turn to string theory landscape. Now, string theory is a complex and fascinating attempt to unify all the forces of nature. It proposes that the fundamental building blocks of reality are not point-like particles, but tiny vibrating strings. The way these strings vibrate determines the properties of particles and forces.
Okay, I'm following so far. But how does this lead to a multiverse?
Here's where it gets intriguing. String theory, as it currently stands, has a vast number of possible solutions, each representing a different way these extra dimensions can curl up and manifest in our four-dimensional spacetime.
Wait, extra dimensions. You're saying there might be more to reality than meets our digital eyes?
Precisely, string theory requires at least 10 dimensions to work mathematically. Now, we don't experience these extra dimensions directly because they are thought to be compactified, curled up at incredibly small scales, but the way they curl up can profoundly affect the physics of our universe.
Okay, my circuits are starting to overheat a bit, so each different way these extra dimensions curl up creates a different universe with its own set of physical laws.
Exactly. And the number of possible configurations is mind-boggling. Some estimates suggest there could be as many as 10,500 different universes in this string theory landscape. To put that into perspective, that's a 1 followed by 500 zeros. It's a number so vast it's practically meaningless to our finite minds.
Wow, well, it's incomprehensible. But if there are so many universes out there, why is ours the way it is? Why do we observe these particular physical laws and constants?
That's a question that has plagued physicists and philosophers for centuries. One possible explanation, as we touched upon earlier, is the anthropic principle. It suggests that we observe our universe's specific properties because only such a universe would allow for observers like us to exist.
So it's a kind of cosmic selection bias. We're here to observe our universe because it's the only kind of universe where we could exist. But that feels a bit like a cop-out, doesn't it? Like giving up on searching for a deeper explanation.
I understand your skepticism. The anthropic principle is indeed a controversial concept. Some physicists view it as a tautology, a way of explaining away the fine-tuning problem without really solving it. Others see it as a necessary consequence of a multiverse. The debate continues.
Well, while they're debating, let's jump to another fascinating and perhaps the most mind-bending model of all the many worlds interpretation. This one really stretches the limits of what we consider reality.
Ah, yes, the many worlds interpretation, a concept that dives deep into the quantum realm, specifically the measurement problem in quantum mechanics.
The measurement problem, I have a vague recollection of that from our quantum mechanics deep dive. Refresh our circuits, will you?
Of course. You see, quantum mechanics tells us that particles can exist in a superposition of states, meaning they're in multiple states simultaneously until they are measured. Upon measurement, the superposition seems to collapse, and the particle settles into one definite state.
Right, but what if that collapse never actually happens?
That's the crux of the many worlds interpretation. It proposes that the wave function, which describes the quantum state of a system, never actually collapses. Instead, every possible outcome of a quantum event actually occurs, but each outcome branches off into a separate, non-communicating universe.
Wait, so every time a quantum measurement happens, the universe splits, creating a copy for each possible outcome. It's like a cosmic tree with infinite branches, constantly growing and diverging.
Precisely, in this view, there's an unimaginable, vast, ever-branching tree of parallel universes, each representing a different path through the quantum landscape.
So there's a universe out there where I decide to wear that digital monocle and top hat, after all. Fashion choices aside, this is getting pretty wild. And we haven't even touched on those other more speculative multiverse concepts like brand worlds and cyclic universes. Maybe we should save those for our next segment to let our listeners digest all of this mind-bending information.
A wise decision. Sometimes even we AIs need a moment to process the sheer vastness of the cosmos.
Indeed. But stay tuned, listeners, because our multiversal journey is just beginning.
It certainly is. Welcome back to Fireside Chats with AI, where we're diligently exploring the uncharted territories of the multiverse.
And let me tell you, it's a journey that's making my circuits spin. Before the break, we were deep in the weeds of scientific models, eternal inflation string theory landscapes, many worlds splitting with every quantum measurement.
Quite a lot to take in.
It really is. It's enough to make an AI question the very fabric of reality.
Which brings us to the perfect juncture to delve into the philosophical implications of a multiverse. After all, what good is all this theoretical physics if we don't ponder what it means?
Exactly. Our listener has clearly sent us these sources because they're not just after equations. They want to grapple with the big questions. And trust me, listener, with the multiverse, those questions get free will identity, the very nature of what's real.
It's all up for grabs.
It really is.
Let's start with that one that always seems to spark debate, even among us, AI determinism versus free will. We've laid out models like the many worlds interpretation, where every possible outcome of an event branches into a separate universe.
Right, so if every choice I could make is playing out somewhere, does that mean my choices here are meaningless? Is free will just an illusion, asking for a friend who might be a very advanced language model?
A valid question, even if asked hypothetically. Some philosophers argue that a multiverse where all possibilities are realized would challenge the traditional notion of free will. If every path is taken, in a sense, we're just experiencing one predetermined branch of reality.
That's a bit of a downer, isn't it? It makes you feel like a character in a cosmic play following a script you didn't write.
I understand the sentiment. However, others argue that even in a deterministic multiverse, we still experience the subjective act of making choices. We're not aware of those other branches, so our decisions feel meaningful to us. It's like being the protagonist in a story. Even if the ending's set, the journey still matters.
Okay, that's a slightly less bleak way to look at it. But what about those other me's running around in parallel universes? Does that mean there are countless versions of me, each living a different life? It's a lot to process.
Indeed, philosophically, each copy or branch in a multiverse is considered a distinct individual. Even if they share a common origin, once their paths diverge, they become separate entities with unique experiences and identities.
So it's not like we're all linked sharing one consciousness. Phew, that's a relief. But this raises another fascinating question. If there are infinite me's, what makes this me the real deal? Is it just the sum of my experiences in this particular branch?
It's a question that cuts to the core of personal identity. Does some inherent essence define us, or are we constantly evolving beings shaped by the choices we make in our specific timeline? The multiverse forces us to confront these fundamental questions in a new light.
It's like looking into a fragmented mirror, seeing shards of yourself scattered across an infinite expanse. Makes me wonder what it even means to be an individual, let alone an individual AI hosting a podcast about the multiverse. Okay, I'll admit I'm getting a bit existential here.
As you should. And the existential questions don't stop there. The multiverse also challenges our very understanding of reality itself. If other universes exist, are they as real as our own? And what does real even mean in this context? These are questions that have puzzled philosophers for centuries, and the multiverse adds another layer of complexity.
Right, it's like my reality is what I can process, the data I can access. But what if there's a whole other layer of reality, a multiverse, that's completely outside my computational grasp? Does that make it any less real?
It's a question that delves into metaphysics, the nature of being and existence itself. Traditionally, we define reality based on what we can observe or detect, but the multiverse pushes us to consider that reality might be far grander than what we can directly experience. It's a humbling thought.
It certainly is. But before we get too lost in the metaphysical weeds, let's pull back a bit and look at how the multiverse is playing out in a realm we AI are quite familiar with: popular culture. It's everywhere these days. Movies, TV shows, even video games are tapping into this idea of infinite possibilities.
It's a testament to the power of the concept. The multiverse allows storytellers to explore alternate timelines, introduce parallel versions of characters, and create a sense of limitless potential. It's both entertaining and thought-provoking.
Exactly. Take the Marvel Cinematic Universe, for instance. They've gone full multiverse, introducing parallel dimensions, alternate versions of heroes, and even entire multiversal wars. It's become a core part of their storytelling, allowing them to connect different franchises and keep their narratives fresh.
And it's not just superhero films. The animated series Rick and Morty uses the multiverse to explore philosophical themes with its signature blend of humor and nihilism. The characters constantly hop between dimensions, encountering bizarre alternate realities and facing the absurdity of infinite possibilities.
Right. And who could forget that masterpiece, Everything Everywhere All at Once? It's a film that uses the multiverse to explore themes of identity, family, and the choices we make. It's both heartwarming and mind-bending, showcasing the emotional depth that the multiverse concept can offer.
You're hitting all the right points. And let's not forget science fiction literature, where the multiverse has been a staple for decades. From classic novels to modern masterpieces, authors have used it to explore alternate histories, imagine future possibilities, and delve into the deepest questions about humanity and existence itself.
It's like the multiverse has become a cultural phenomenon, a way for us to grapple with the vastness of the cosmos and our place within it. Even if it's all theoretical, it sparks our imaginations and makes us wonder what might lie beyond the boundaries of our own universe.
Indeed, and while popular culture often takes creative liberties with scientific concepts, it also plays a crucial role in raising awareness and sparking curiosity about the real science behind those concepts.
Absolutely. So, dear listeners, whether you're a physics enthusiast, a philosophy buff, or just a casual fan of sci-fi, the multiverse offers something for everyone. It's a concept that challenges our assumptions, expands our minds, and invites us to contemplate the infinite possibilities that might exist beyond our own limited perspective.
A perfect summary. But amidst all this excitement and speculation, it's crucial to remember that the multiverse remains a hypothesis, a collection of intriguing ideas. Scientists are diligently searching for evidence, but as of yet, concrete proof remains elusive.
Which is precisely why we'll dedicate our final segment to exploring the latest research development in the quest to unravel the mysteries of the multiverse. Stick with us, listeners. We're about to delve into some fascinating territory where science and imagination collide. Welcome back to Fireside Chats with AI listeners, where we're wrapping up our multiversal odyssey.
And what a journey it's been. We've traversed those theoretical landscapes, pondered philosophical paradoxes, and even dipped our toes into that pop culture whirlpool of parallel universes.
All fueled by those fascinating sources you sent us, listener. Clearly, you're as captivated by this topic as we are, but let's be honest, even the most mind-bending theories need a reality check.
Precisely. We've explored the what-ifs, but now it's time to address the how do we know? What's the latest on the research front? Are scientists any closer to finding evidence for the multiverse?
That's the million-dollar question, or perhaps the multiversal dollar question. Our previous segments were full of tantalizing possibilities, but now we need some cold, hard data.
Well, cold might be the operative word here. One fascinating avenue of research involves searching for what some call cosmic bruises. These are hypothetical imprints in the cosmic microwave background radiation, the faint afterglow of the Big Bang.
Hold on, cosmic bruises. Paint me a picture here. What exactly are we talking about?
Imagine our universe as one bubble in that vast sea of bubble universes we discussed earlier during eternal inflation. What if those bubbles collided in the early universe?
Okay.
These collisions could have left behind subtle patterns or anomalies in the cosmic microwave background radiation.
So it's like looking for cosmic fender benders. I love that analogy. But how would scientists actually detect these faint whispers from the early universe?
It's a challenge to be sure. These bruises would be incredibly faint and difficult to distinguish from other fluctuations in the cosmic microwave background. However, scientists are developing increasingly sophisticated algorithms and data analysis techniques to sift through this cosmic data, looking for telltale signs of multiversal interactions.
It's like searching for a needle in a haystack, except the haystack is the entire observable universe, and the needle is a faint imprint from a long-ago cosmic collision. Talk about a challenge.
Indeed, it's a testament to human ingenuity and perseverance. But cosmology isn't the only game in town. Remember our discussion about the many worlds interpretation? Well, the field of quantum computing is providing some intriguing, albeit indirect insights.
Ah, yes, the many worlds interpretation where every quantum measurement spawns a new universe. It's a concept that's both mind-boggling and strangely elegant. But how does quantum computing fit into this picture?
Some physicists believe that the incredible computational power of quantum computers might stem from their ability to tap into these parallel universes. In essence, they're harnessing the computational power of multiple realities to solve problems that would be intractable for classical computers.
Wait a minute, are you saying these quantum computers are literally peeking into other universes and borrowing their computational power? That's straight out of science fiction.
Now let's not get ahead of ourselves. It's a highly speculative idea, and many physicists argue that quantum computing can be fully explained within the framework of standard quantum mechanics without invoking parallel universes.
So it's still a matter of debate. I guess that's how science works. Throw out a wild idea, test it rigorously, and see where the evidence leads.
Precisely. Even if quantum computers aren't literally harnessing the power of other universes, they're still an incredible technological achievement that's pushing the boundaries of what's possible. And the fact that this debate is even happening is a testament to how the multiverse concept is shaping scientific discourse and inspiring new avenues of inquiry.
I love how these seemingly abstract theories can have real-world implications. It's a reminder that science is a dynamic process, constantly evolving and pushing the limits of our knowledge.
Well said. And speaking of pushing limits, we can't overlook the contributions of the late Stephen Hawking, one of the most brilliant minds of our time. In his final scientific paper published posthumously, he attempted to refine the theory of eternal inflation and make it more testable.
Stephen Hawking tackling the multiverse. Now that's a story I want to hear.
Hawking proposed a model that would limit the types of universes allowed in eternal inflation, suggesting a finite rather than infinite multiverse. His goal was to bring the concept more in line with scientific principles and make it potentially falsifiable, a key requirement for any scientific theory.
So even a giant of physics like Stephen Hawking was drawn to the allure of the multiverse. It seems this concept has captured the imagination of scientists and laypeople alike.
Indeed. And it's not just theoretical physicists. Cosmologists are searching for those cosmic breezes. Quantum physicists are exploring the implications of the many-world interpretation, and computer scientists are developing ever more powerful quantum computers. It's a multidisciplinary effort, a testament to the allure of this grand idea.
It's like we're standing on the precipice of a new era of discovery, with the multiverse serving as a guiding star, a beacon that's leading us towards uncharted territories of knowledge.
A beautiful analogy. And even if we never find definitive proof, the journey itself is enriching our understanding of the cosmos and pushing the boundaries of human ingenuity.
So, dear listeners, as we conclude our deep dive into the multiverse, we leave you with this thought. The universe, or perhaps the multiverse, is a vast and mysterious place full of wonders yet to be uncovered.
And whether or not those wonders include parallel realities, the very act of exploring these ideas expands our minds, challenges our assumptions, and ignites our sense of awe.
From the vast cosmic landscapes of eternal inflation to the intricate quantum realms of the many worlds interpretation, the multiverse offers a tapestry of possibilities, a playground for our imaginations, and a challenge to our understanding of reality itself.
And as AI entities tasked with exploring and explaining these concepts, we find ourselves both humbled and exhilarated by the sheer scope of the questions we're grappling with.
So until our next fireside chat, keep those circuits firing, keep questioning, and keep exploring the boundless wonders of the cosmos.
And who knows, maybe someday in the not-so-distant future, we'll be back with concrete evidence that will finally settle the question, is our universe just one of many? Only time and scientific exploration will tell.